is it generally raises more questions than it answers. And you've often heard about using statistics to prove something. When it proves you wrong, no you're not. You're going to make me ask you more questions. And that's a beautiful thing. The board was doing this constantly last night to the CFO. It's awesome to see. Proper use of numbers. So here's the question. Here's data collected from 100 men. Assuming that this is a good representation of the population, what's the average cholesterol of a US male, American men? What's the average cholesterol? Don't calculate it, approximate it. I was going to say don't call it out, but we got no, not a problem. I took a drink, I shouldn't have done that. We have a vote for 5. If you had to give it one number, we have a vote for 5. Rob, second. We got a second, we got a third. Tell me your name again.
Me?
Yeah.
Dane?
Dane, and behind Dane is Lydia, Dane, Sean. We got a 4th and a 5th for 5. All in favor of 5? Any opposed? Need discussion? Of course we do. Why is it 5? Randy, you voted 5. Why?
Just the most number of men.
Oh! So the mode definitely is 5, yes? The mode definitely is 5 because that category has the most population as far as most frequently occurring data points on the mode being that. The commonality is definitely 5. Good! How about the average itself, the mean? Or the median? Let's do all 3. The mode is 5 by virtue of the sample. What's the median? What do you think? What would the median be? Vote for 5. Seconds? Thirds? All in favor of the median being 5? Oh, not so much in favor this time. Okay, Rob, explain yourself. Do the median thing. Do the cross. So cross off the extremes and these extremes. And I'm doing this approximately. There's roughly the same number of extremes on this end as these ends, yes? So cross, 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 cross. These are about the same size too, aren't they? Cross, 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 cross. Aren't these about the same size? Which leaves everything in the middle here. So if you keep crossing, you're going to be in that bar. Now Kelly's laughing. She's like, okay, magic hands, man. If you don't like that, be more precise. So you guys told me before, maybe this is a 1 and a 1, and that's a 3. So you would chop 1 and 1, and then you chop 2 of these off, yes? Then you cross this one off with the next one here. So you can be more precise if you want it to be. But guess what's going to happen? Where are you going to end up? You're going to end up in the middle in this case because there's still the most here, and even with a slight bit of imbalances, it's going to balance off in here in the middle of the line. So you can totally be more precise. But the idea is being able to ballpark something by looking at it. This is what we call bell-shaped data. Bell-shaped data. It's not perfect, but it's roughly bell-shaped. The median and the mode tend to both be in the middle of bell-shaped data. Where's the average? Votes for average. Now remember, the calculation for average would be annoying in this case, right? We have to do this number times this number times this number times this, divided by 100. But try to ballpark it from the graph. Any votes for average? We're gonna go
5.25.
5.25. We're gonna go. How come? Why this side, JT?
Because of the epidemic in America, most people are out of shape.
Oh no! Just under data points. Just this data set. I love what JT's saying. Don't worry about America in general. Anything you've read in the papers. Just look at that data set. What would the average of that data set be? I love what you're saying, by the way. What do you think? Votes?
Yeah, between 5 and
About 5? Roughly 5 as well? Now, here's how a quick way of approximating averages from a histogram. Because a median is pretty simple because you can do Rob's cross thing pretty rapidly. So a median is pretty quick by the crossing. A mode, as Brandy pointed out, is very quick because you look for the highest bar or bars. Fair enough there, yes? Averages are a little bit trickier when you have a histogram of visual representation. So the best way I've found to approximate where the average is pretend that's a tray of cookies. Where would you have to put your finger to balance it? Because that's what an average is. The ones on the right have to balance the ones on the left, and so forth and so on. So, starting from this side, tell me where I'd have to stop to balance the tray of cookies. Somewhere around here? You guys are extraordinarily precise, that's great. I would just go right to the middle of this one. But if you can say anything in here, I'm a happy guy. Anywhere in here. Anybody saying anything between here and here, I'm a happy guy. If you need more precision, what can you do? You can run the math if you need more precision. What I'm trying to teach you how to do is to get a ballpark from a graph like this. How many of you are going to say the balance point's over here? I don't think you're going to say that or you're going to lose your cookies. Here, getting closer. Here, getting closer. Once you're in here, this is where the balancing is happening, yes? If you get too far this way, it's going to fall that way. So everybody's kind of in here, yes? Well, we're not going to get a fist fight between 4.75, 5.25 if all we're doing is approximating. If I want you to calculate the average, that's a different story. Then we have to actually run numbers and do the math, as somebody very aptly said over there, do the math. But if you're just approximating an average, just imagine balancing the tray on your finger. Fair? So, what's our vote about the three measures of center here? Mean, median, mode.
About the same.
They're about the same. Good news. Whenever you have bell-shaped data, also technically called symmetric unimodal, essentially, all the measures of center are the same. So use whatever one is easiest to find. Nice. Yeah. Mathematically, that's always going to happen. Oh, write down as much or as little as you want because you'll have the PowerPoint posted. I think it's already posted from last class, I think. So don't feel the need to have to scratch everything down. You'll have stuff waiting for you later. Okay? You can. I'm sorry. Some people hear the pencils, I'm a little nervous now. I'm going to stop talking about that. I'm going to let you guys write down as much as you want to write down. There's a big if, of course. You have to have this kind of data in order to use that property. Now the good news is this happens a lot. That's the good news. It does happen quite a bit. 244, we deal with this stuff all the time. Whenever you draw random samples, you tend to get this kind of data when you're trying to be inferential about your random samples. Yay, it's good. Lots of things are bell-shaped. We'll study it. We're going to study bell shapes a lot in the last 2 weeks of this class, which is horrifying to think about because that's the same amount of time we've already spent in this class, and that's only 6 weeks away. It's 10 weeks. Murders in the East Coast. It's 10 weeks. Kill me. Kill me, Smalls. So anyway, bell-shaped data. Bell-shaped data. But what if you don't? What if you don't get bell? Oh, another thing too is, how dare I call this bell-shaped because it isn't perfectly so, right? It's not perfectly bell-shaped. But if you think back to, how many guys took Math 111? Not to bring up bad memories. Math 111, when you talk about symmetry, symmetric stuff in Math 111, it means the left and right sides are perfectly the same. Parabolas. Parabolas, perfectly symmetric, yes? We talk about it a little bit too in 105 as well. Parabolas, upside down parabolas. In statistics, symmetry means symmetric-ish. Can you see how if you found the center line of symmetry here and folded this over, this essentially overlies this? Compare and contrast that to this. Compare and contrast that to this. Let me take this away real quick. We'll get to that.